enters in anxiety. How do we know that stars are made primarily with hydrogen and helium?
We know this because the spectroscope shows helium and hydrogen present in the sun.
And if stars have similar emissions to certain elements, then we know that those elements appear in that star.
How does this relate to the Big Bang, you ask?
Well, shortly after the Big Bang occurred, the universe was a hot, dense place without atoms. Lighter elements such as helium and hydrogen were the first to form.
This brings up the question as to why the oldest stars have less than 1% of heavier elements, which is much less than some of the newer and younger stars.
Younger stars are able to form heavier elements because whenever an old, massive star dies, it releases heavy elements which enrich new stars and allow them to create heavier elements using elements they got from old stars.
This means that the oldest stars didn't have stars before them to enrich them with heavier elements, so there are very few of them.
New stars are gradually getting more heavier elements, which is why there is such a difference between new and old stars.
Pauses in quiet. Did the model with balloons and sequins represent a spread of hydrogen and helium well?
It was a decent model in the grand scheme of things. It represented how the elements spread with the original bang very well, and showed how helium and hydrogen were in the most abundance compared to other elements. This is because hydrogen and helium are lighter and easier to form.
Of course, it wasn't perfect. Such experiments and models will always have inaccuracies, considering there are certain aspects and obstacles we can't have represented, and there are always things like human error that can mess with observations.
Strong.
You can stop it now.
You should have left it, and there's